So the minimum value we are going to get is minimum of 1 by 4 comma 0. Here the minimum value is equal to 0. See here in the second equation it is greater than or equal to minus 6. Let us convert this as positive. What is the key element? The intersection of the incoming and outgoing row and column will give the key element. Hello dear students, welcome to this session of OR Operation Research class. I am Mr. Niranjan, faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the problems based on degeneracy. Today also I will take one more problem on degeneracy of LPP. Now solve the degeneracy in the following problem and solve. So we have to resolve the first. First resolve the degeneracy in the given LPP and solve it. Now what is the problem given? Max z is equal to, maximum of z is equal to x1 plus 2x2 plus x3 subjected to the constraints 2x1 plus x2 minus x3 less than or equal to 2, and second equation minus x1 plus x2 minus 5x3 greater than or equal to minus 6 and 4x1 plus x2 plus x3 less than or equal to 6, where x1, x2, x3 are all greater than or equal to 0. Now see here in the second equation it is greater than or equal to minus 6. Let us convert this as positive. To convert this minus 6 as positive, multiply this equation by negative sign. If you multiply by negative sign, what we will get? The same values. Max z is equal to x1 plus 2x2 plus x3 subjected to the constraints. What are the constraints? 2x1 plus x2 minus x3 is less than or equal to 2. If I multiply by negative sign, then minus into minus plus x1 minus x2 plus 5x3, and you know this greater than or equal to will convert to less than or equal to, minus into minus it becomes plus, and the third equation is same as it is 4x1 plus x2 plus x3 which is less than or equal to 6. Now this is the converted form of the given LPP. Okay. Now see here all less than or equal to, just using by adding the slack variables and surplus variables. Now this can be modified as, the modified form of this equation is by considering the coefficient of S1, S2, S3 as 0, 0 and 0. The modified form, the standard form of the given equation is max z is equal to x1 plus 2x2 plus x3 0 s1 plus 0 s2 plus 0 s3 subjected to the constraints 2x1 plus x2 minus x3 plus s1 is equal to 2 and x1 minus x2 plus 5x3 plus s2 is equal to 6 and 4x1 plus x2 plus x3 plus s3 is equal to 6, where x1, x2, x3, s1, s2 are all greater than or equal to 0. Let us write the coefficients for this. So what is the converted standard form? Max of z is equal to x1 plus x2 x2 plus x3 plus 0 s1 plus 0 s2 plus 0 s3 subjected to the constraints. Now let us write the coefficients for the constraints. So here this is x0, x1, x2, x3, s1, s2 and s3. Now for the first equation we have coefficient of x0 is 2, coefficient of x1, x2, x3 are 2, plus 1, minus 1, S1 is 1, S2 and S3 are 0, 0. For the second equation, this is 6, 1 minus 1, 5, 1 minus 1, 5, S1 is not there, S1 is 0, S2 is 1 and this is 0. For the third equation, 4, this is 6, coefficient of x1 is 4, 1, again x3 is equal to 1, S1 is not there, S2 is also 0 and 1. Now just identify the identity matrix formed by these coefficients. So this will form an identity matrix. So this is an identity matrix of order 3 rows 3 column. So that is 1 0 0 0 1 0 0 0 1. So we can consider the variables x1, s1, s2, s3 for the construction of the simplex table. Now after writing the coefficients, let us observe the initial identity vector. Identity vector 1 0 0 0 1 0 0 0 1. So this will forms an identity vector, identity matrix with S1, S2 and S3. So therefore in the initial basic vectors we are going to consider the initial vectors are S1, S2 and S3 with the coefficients 0 0 0, and the coefficients of the constraints are as usual. I can write all these values 2 6 6, 2 6 6, and here 2 1 4, 2 1 for x1, for x2 1 minus 1 1, 1 minus 1 and 1, for x3 it is minus 1 5 and minus 1 5 and 1, for S1 1 0 1 0 0, for S2 0 1 0, for S3 0 0 1. Now these are the values and these are the entries. Now let us find out, as usual, find out the value of Zj. Zj, since all the values in Cj are 0 0 0, if you multiply with 0 you will get 0, 0 into 2 is 0, 0 into 6 is 0, 0 into 6 is 0. So therefore all these values we are going to get it as 0 0 and 0. So just subtract this. 0 minus 1 is minus 1, 0 minus 2 is minus 2, 0 minus 1 is minus 1, 0 minus 0 0, 0 minus 0 0, again you will get 0. Now identify the least negative value in delta J. Least negative value is minus 2. This is the least negative, therefore this is the incoming variable. This is the incoming variable. So x2 is the incoming variable. Okay. Now identify the outgoing variables. Now these are the incoming variables. Now find out the ratio. The ratio is equal to, ratio is given by, ratio is equal to x0 divided by x2. So x0 divided by x2. So what are the values of x0? 2, 6 and 6 divided by 1, minus 1 and 1. 2 by 1 is equal to 2. Again 6 by minus 1 is equal to minus 6. Again 6 divided by 1, 6 divided by 1 is equal to 6. So 2, minus 6 and 6 are the ratios. So x0, 2 by 1 is 2, 6 by minus 1 is minus 6, 6 by 1 is equal to plus 6. Now identify the least positive value. Here the least positive value is plus 2. So therefore these are the outgoing variables. So the outgoing variables are, these are the outgoing variables. Now, okay. Now here just identify the key element. What is the key element? The intersection of the incoming and outgoing row and column will give the key element. Here this 1 is the key element. Since already it is 1, there is no need to convert. If it is other than 1, we have to divide by that particular element. The entire row is divided by that key element. Since it is 1, there is no need to convert that. So we can keep R1 as it is. So in the next iteration table, so row 1 will be the same. And whereas R2 dash and R3 dash, row 2 and row 3 dash, convert this minus 1 as 0 and again this 1 as 0. For this we can use the elementary row operation. R2 dash is equal to, if you add these two, this will become 0. If you subtract these two, it will become 0. Then and check for the degeneracy. Okay. Now let us go to the next table. R1 dash is equal to R1 as it is. So I will write the same. And here what are the incoming variables? X2 are the incoming variable, and what are the outgoing variable? S1. So S1 is replaced by X2. So in the next iteration, iteration number 1, so X1 is replaced by X2, the coefficient of X2 is plus 2 and S2, S3 coefficients are 0 as it is. Now the elements R1 dash is equal to R1 itself. So here is same 2, 2, 1, 2, 2, 1, that is R1 dash is equal to R itself. R1 dash and R1 are same. So 2, 2, 1, minus 1, 1, 0 and 2. So 2, 2, 1, minus 1, then 1, 0, 0, 1, 0, 0. Now next convert this minus 1 as 0. For this, what is the operation we are going to use? Add these two, that's all. R2 dash is equal to R2 plus R1 dash. So if you add these two, you will get the same answer. So 6 plus 2 is 8. Here it is 8. Again, yes, 1 plus 2 is 3. Minus 1 plus 1 is 0. 5 minus 1 is 4. 0 plus 1 is 1. 0 plus 1 is 1, 0. So 4, 1, 1, 0. 4, 1, 1, 0. Now convert again this element as 0. For this we can subtract this. R2 minus, so R3 dash is equal to R3 minus R1 dash. So what are the elements of R3? Here we have R3, 6, 4, 1, 1, 6, 4, 1, 1, 6, 4, 1, 1, 0, 0, 1, 0, 0, 1. Elements of R1, 2, 2, 1, minus 1, 2, 2, 1, 1, 2, 2, 1, minus 1, 1, 0, 1, 0, and again 0. Now subtract these two, that's all. 6 minus 2 is 4, 4 minus 2 is 2, 1 minus 1 is 0, minus into minus plus 2, minus 1, 0, and 1. That's it. Now, I'll write these elements here. So that is 4, 2, 0, 2, 0, 2, minus 1, 0, 1. These are the values. Okay. Similarly, now just as usual, find out the value of Zj. Then delta j is equal to Zj minus Cj. Now what is delta j? Multiply these elements. 2 into 2 is 4 plus 0 is equal to 4. Again 2 into 2 is 4 plus 0 is 4. Again 2 into 1 is 2 and 0 is 0. 2 into minus 1 is minus 2 plus 0 is minus 2. This is minus 2. Again 2 into 1 is 2 plus 0 is 2 as it is. 2 into 0 is 0. Remaining are all 0. Again 0 plus 0 is 0. Now find out the value of delta j minus Cj. Just subtract. This is 4 as it is. 4 minus 1 is 3. Again 2 minus 2 is 0. Minus 2 minus 1 is minus 3. 2 minus 0 is 2. 0 minus 0 is 0. 0 minus 0 is equal to 0. Now identify the least negative. Here least negative is minus 3. So therefore these are the incoming variables. Incoming variable. That means x3 is the incoming variable. Now find out the ratio. The ratio is given by, ratio is equal to x0 divided by, what are the incoming variables? X3. Now what is x0 here? X0, these are the values of x0. 2, 8 and 4. So 2 divided by minus 1. 2 divided by minus 1 is minus 2. Again 4, yes, 8 divided by 4. 8 divided by 4 is equal to 2. Again 4 divided by 2. 4 divided by 2 is equal to 0. So since these two values are same, therefore there is a tie between these two. So the values of S2 and S3, R2 and R3 column will have the same ratio as 2. So therefore there is a tie and we have to remove this tie. This degeneracy has to be removed. For that we have to find out the minimum of the element. Now how to find the minimum of the element? So here just identify the identity matrices. Yes, here this is 1 0 0 0 1 0 0 0 1. This will form an identity matrix. So that is here x2, then s2 and s3. x2 we have 1 0 0 and 0 0 1. To find the minimum ratio, we are going to use the formula. Minimum ratio is equal to the elements of first column of the unit matrix divided by the corresponding incoming elements, or the elements of second column of the unit matrix divided by the corresponding incoming elements, or similarly the elements of third column of the unit matrix divided by the incoming variable. So using that concept, we have to find out the minimum. If there is again a tie, we have to go for the next step. That's it. Okay. The ratio is found to be x0 divided by x3. x0 is equal to, the value of x0 is 2, 8 and 4 are divided by x3. x3 incoming variable, that is minus 1, 4 and 2. So 2 by minus 1 is minus 2, 8 divided by 4 is 2, 4 divided by 2 is equal to 2. So here these two values are same. The values of the ratios in R2 and R3 are same. So therefore there is a tie, and hence there is a tie in this. So this tie is to be eliminated. To eliminate this tie, what is the formula we have to take? We are going to find the minimum value. So the minimum ratio is determined by dividing the unit matrix, the corresponding elements of the unit matrix divided by the incoming variables. Elements of the first column of the unit matrix divided by the incoming variable, or similarly if there is again a tie, we are going to go for the second element. So the elements of second column of the unit matrix divided by the incoming variable. Similarly, the elements of the third column of the unit matrix divided by the incoming variable will give the minimum ratio if it is a tie again and again and again. Here the elements of x2 is considered as the first column 1 0 0, and the elements of s2 and s3 are considered as the second column and third column 0 1 0 and 0 0 1. So these elements are divided by the incoming variable. So that is minus 1, 4 and 2. So if you divide 0 by minus 1, 1 by 4 and 0 by 2, again 0 0 1 divided by these incoming variables. If there is a tie, we have to go for the minimum value. So using this, so the minimum value is determined divided by the elements of first column of unit matrix divided by the incoming variables, corresponding incoming variables, right. So again see here the elements of the unit matrix of first S2, here consider S2 is 0 1 0 0 1 0. These elements are divided by incoming variable, that is x3, that is nothing but 0 by minus 1 is equal to 0. Again 0 divided by 4 and 1 divided by 4, this is equal to 0.25. Again next element is we have 2, so 0 divided by 2, 0 divided by 2. So this is again there is 2 zeros in this column, so therefore again we have to go for the next step. So if this process is repeated, so the minimum value we are going to get is minimum of 1 by 4 comma 0. Here the minimum value is equal to 0. So the minimum of this is 0 in S3, therefore this S3 is the outgoing variable. In the next column this S3 is replaced by x3, and the coefficients x2, s2, x1 are 2, 0 and 1. Here further this is we are going to take out from this, so therefore this is the outgoing variable and these are the incoming variables. So in the next table convert these two as 1 by dividing entire element by 2. Now consider R3 dash is equal to R3 divided by 2. So what are the elements of R3? We have 4 2 0 2, 4 2 0 2, minus 1 0 1, minus 1 0 1. These are divided by 2. 2 1 0 1, minus 1 by 2 0 and 1 by 2. So I will substitute here for R3. What are the elements of R3? 2 1 0, 2 1 0, 0 1 by 2. Okay. Now similarly convert these two elements as 0. So let us convert this as 0. For that we can use R1 dash is equal to R3 dash plus R1. What are the elements of R3 dash? We have 2 1 0 1, minus 1 by 2 0 and 1 by 2. The elements of R1 dash are 2 2 1 minus 1, 2 2 1 minus 1, 1 0 0, 1 0 0. Add this, 2 plus 2 is 4, 1 plus 2 is 3, 0 plus 1 is 1, 1 minus 1 is 0. This is minus of, plus 1 is equal to plus of, and this is 0 plus of. So I will write the elements as 4 3 1 0 1 by 2 for R1 dash. 4, 3, 1, 4, 3, 1, 0, 1 by 2, 0, 1 by 2, 0, 1 by 2, 0, 1 by 2. Okay. Finally, find out R2 dash. R2 dash is equal to, so here R2 dash, convert this 4 as 0. So to convert this as 4 as 0, we can use R2 dash is equal to, R2 dash is equal to R2 minus 4R1. So what are the elements of R2 dash? R2 we have here R2 831 8304 041 83041 10, and this is elements of R2 elements minus 4 times R1. Just multiply this with the 4. So multiply this 4 2s are 8, again 4 1s are 4, 4 into 0 0, 4 1s are 4, again 4 into minus of is minus 2, again 4 into 0 0, again 4 into off is 2. Subtract this, minus 1 0, again this is 0, 1 minus into minus plus 3, 1 minus 0 is 1, minus 2. These are the values we are going to get. 0 minus 1 0 0, 3 1 minus 2, 3 1 minus 2. Just as usual, find out the value of Zj and delta j. Zj, 4 into 2 is 8, 8 plus 0 plus 2 is equal to 10. So this is 10. Again 3 2s are 6, 0 plus 1, 6 plus 1 is 7. Again 3 1s are 3 plus 0 is 2 1s are 2 plus 0 is 2. Again 2 into 0 0, 0 into 0, 1 into 1 is 1. Again 2 into 1 by 2 is 1. Again 0 minus 1 by 2, 1 into minus 1 by 2 is minus 1 by 2, that's equal to plus 1 by 2. Again 0 plus 0 plus 0 is 0, 2 into 1 is 1 by 2 is 1, plus 0 plus 1 by 2, this is equal to 3 by 2. So now find out the value of delta j. So this is 10 as it is, 7 minus 1 is 6, 2 minus 2 is 0, 1 minus 1 is 0, 1 by 2 minus 0 is 1 by 2, 0, 3 by 2 minus 0 is 3 by 2. Find out, see, check whether all the values in delta j, since delta j is greater than or equal to 0, therefore the optimality is reached. The optimality is reached. What is the optimal value? So here the optimal value is equal to 10 is the maximum value at x2 is equal to 4 and x3 is equal to 2 and x1 is equal to 0. So therefore maximum value max z is equal to 10 at x1. What is the value of x1? x1 is not there, x1 is 0, x2 is equal to 4 and x3 is equal to 2. So this is the maximum value. So therefore the given problem has maximum at x1 is equal to 0, x2 is equal to 4 and x2 is equal to 2 and the maximum value is 10. So this is how we are going to solve the problem using degeneracy. Now here the very important concept is, once there is a tie, just eliminate the tie by using the formula, finding the minimum value. The minimum value is given by elements of the first column of the unit matrix divided by the incoming variable. Similarly, once again a tie means the elements of the second column of the unit matrix divided by the incoming elements. Again, once again, if there is a tie, we will go for the next step, that is the elements of third column of the unit matrix divided by the incoming variable. So the process is repeated until the tie is eliminated, the degeneracy is eliminated. So then we will get the final solution. So in this problem, the final value is max z. So if you want, you can substitute these values and verify. That's it. So this is how we are going to solve a problem using degeneracy. That's all regarding this session. Let us meet with different concept in the next class. Thank you very much.